All right, so the reason we use scientific notation is because in science, which that's where we get scientific, we deal with very large and very small numbers. And that's actually a very important concept. We're dealing with very large and very small numbers. And I'm thinking to myself, I wonder when we found out that, things were really big or things were really, really small. And it wasn't that long ago where we're thinking, okay, I see stars at night, and people have seen it since the beginning. But then actually to measure how far they are, you're dealing with a very large number. And then when they started getting like their microscopes and seeing things on a smaller scale, man, that is so small, it's actually very, very small. So when we deal with those types of numbers, we need scientific notation. But you may be thinking, on some of these problems, wouldn't it just be easier to not deal with scientific notation, just like put it out on a calculator? You're going to find out that some of your problems, if you just put them into a calculator, will not work because they're just too big or too small. So how do we deal with it? That's the point of the lesson. Okay, so scientific notation looks like this. A times 10 to the nth power. So that's the format it's going to have. And I didn't tell you this last year, but I didn't write this down, but I'm going to tell you now because we've dealt with compound inequalities. It has to be in this form, A times 10 to the nth power, where A is greater than or equal to 1 and less than 10. So does anyone know how to understand what this number is? What does A have to be? It has to be 1 or bigger, but not bigger than 10. So basically a single digit, not a single digit. It's a number between 1 and 10, but it can also be 1 itself because it could be equal to. And then n is an integer. So not a fractional exponent, but an integer. So positive or negative whole number, if you want to think of it that way. So that's important to know. So why do we use it? Very big, very small numbers. How is it written? It has to be in this format where A is between 1 and 10, including 1, and n, that exponent, is an integer. Okay? So let's look at some problems, see how we work with them. This is from last year, so this is not new or deep or hard, but it is going to be necessary to get onto the more difficult concepts. So example 1a. Excuse me, thank you. If I'm reading that right, it's 98 billion. 98 billion 700 million. How many of you would agree that that's a big number? Whatever it is, it's big. Yeah, it's big. It's a big number. So scientific notation is going to be helpful for dealing with this number, not only how to write it, but you're going to see later on in the lesson how to multiply or divide it if we needed to. Okay, so I'm going to write it in the format A times 10 to the n power, where A is a number between 1 and 10, and n is an integer. Okay, so does anyone remember how to do this? Like, what do I do to get that number, big number, into a scientific notation format? Emery? Okay, you're getting there. Where does that decimal have to go? Well, right now it's over here. Where does it have to go? There's only one spot where it can go where it's properly in scientific notation.
In between the 9 and the 8.
It has to go right here. So how many times did it move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So I get 9.87, and you could drop out all those zeros after it. 9.87 times 10 to the what power? How many times did I move that decimal? 10 times. Now, I think the biggest part about this first part of the lesson, Mr. A, how do you know if that's a positive 10 or a negative 10? Well, let me ask you again, was this a big number to start with? Is that a big number? So big numbers have what kind of exponents? Positive, always. Big numbers, positive exponents. And I'll summarize that in a little bit. Okay, look at B then. Example 1b. 0.0000056. Be careful on the zeros because sometimes you may write one too many, and that will throw off your answer. Okay. So I want to write in scientific notation. I'll circle this if you needed that answer. Right now, it is not in scientific notation because it's not in this format. Where do I have to move the decimal? Where's the only place I can move that decimal to get it into that proper format for A? Carson? Yeah, how many times, or where do I have to move? Like, where should it be at the end of this? 5.6. Yeah, it should be in between the 5 and the 6. So it's going to be 5.6 times 10. How many times did I move it? 1, 2, 3, 4, 5, 6 times. Now, was this a very big number or a very small number to start with? Small number. It's a negative exponent. Small numbers have what kind of exponents in scientific notation? Negative. Always. So if you're like, I started with a big number, how do I have a negative exponent? You did something wrong. I had a really small number, but I have a positive exponent. You did something wrong. So be careful with that. Yes, sir. Oh, look at that. Okay, hold on. How many of you would agree that 10 to the negative 6, based on what we looked at yesterday and this morning, would be 1 over 10 to the positive 6? Is that true? And that's the same value. So here, 5.6 times 10 times 1 over 10 to the 6th. Now, that's what we were doing last lesson, but the format for scientific notation is you keep it a negative exponent or positive depending on what it is. So this right here is equal to this, but this is a proper format for scientific notation. So that's a good eye on that. So do these relate to the last 2 lessons maybe? You'll see it more as we get on into this lesson. Go to page 509. Just make sure you guys get this concept. Do number 7, please. Write that. Oh. On number 7, I want you to write the radius of Jupiter in scientific notation. So did you hear what I just said? I want you to write the radius of Jupiter in scientific notation. Nope, don't round it. Is this the radius of Jupiter in miles, by the way? So then write that in scientific notation. Gotta make sure I have the right number. Okay. All right. How many of you got 4.4419 for that first part? Times 10 to the positive or negative? Okay, somebody tell me why it's positive, not negative, Claire. Okay, you can say that. And then what was the explanation I wanted to give you? Yes, Alex. Yeah, it's a big number, positive exponent. So that's another way. The reason I don't go with the left-right kind of idea is because sometimes we mix it up when I'm going from here to here, that'll work. When you go to the left, you make that go up once. But if I'm having to write this back into standard form, we have to switch it around, and I don't even want you to deal with that. Just think big numbers, positive exponents, little numbers, negative exponents. That'll help you out. Do number 10. So on number 10, the wavelength of cadmium's green line, and then they give you that number. Oh, that's not. Okay, if I want to write it in proper scientific notation, where do I have to move that decimal? Where does it go? Matt? Okay, it becomes 5.09. 5.09. And this can be times 10 to which power? How many times did I move it? I moved it 1, 2, 3, 4, 5. Positive or negative? Negative. Because isn't 0.0000509 a small number? So it should be a negative exponent. So 5.09 times 10 to the negative fifth. How many of you are comfortable doing that? Okay, good. That's the first part of the lesson. The second part, let's go back to example 2. Example 2, we'll do 2a. So I kind of alluded to this already. You have to write a regular standard number into scientific notation, and then you have to write scientific notation into standard. So what do I mean by that? Example 2a, they give me 3.45 times 10 to the fifth. Without even starting this up, is this a big or small number? It's a big number. Why is it a big number? How do I know that without even writing it out? Because Claire? What kind of exponent is that? Positive or negative? Positive. It's got to be a big number. So you have two choices. You can either move the decimal to the right 5 times, or you can move it to the left 5 times. Which one's correct, though? Yes, ma'am? To the right. I'm going to move it 1, 2, 3, 4, 5. This is where the decimal place goes. And what do I put in these empty spots? Your zeros. And I need you to write the number correctly with the right commas where they belong. So this answer would be 345, comma, 000. 345,000 is your answer to 2A. Okay, you guys okay with that? So you're going back and forth. By the way, this is scientific notation, and this is standard form. Scientific notation, standard form. Why do you think we call it standard form? Because this is how we, what do you think? Standard form. What does standard mean?
How we say normal.
Yeah, that's how you isn't this how you normally look at numbers? Just the commas and zeros at the end and all that. So it's your normal way of looking at things. All right, let's do B. 9.72 times 10 to the negative fourth. That's got to be big, right? It's got to be a huge number. What? Oh, why is that big? Negative exponent. Okay, so my choice is to go move that decimal to the right or move it to the left. Which way do you want to go? To the left. 1, 2, 3, 4 times. It goes right here. Fill in those empty spots with zeros. Oh, that's huge. Is that big? No. It's actually 972 millionths. So if you cut something in a million pieces, you would get 972 of them, which you're like, wait, isn't that a lot? 972 millionths. So can you shred this into millions? 972 would be some like speck that you may not be able to see. So that's small. Okay, I want you guys to try back on 409 or 509. Number 9. Write that in standard form. So I want you to write the maximum distance from the sun of Pluto in standard form. So the maximum distance from the sun of Pluto, which used to be a planet, by the way. Oh, man, now it's not anymore. I'm upset. Pluto is always kind of out there. It's a dwarf planet, yeah. So it's not big enough. That's discrimination right there. Okay, so 4.5. Oops. All right, where should I move that decimal? To the right or to your left? To the right. If I move it to the left 9 times, what am I going to get? A really small number. I'm going to get something point blah 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 0.000045514 miles. That's talking about less than a mile, and that is not the distance from Pluto and the sun. 1, 2, 3, 4, 5, 6, 7, 8, 9. Decimal point. And I get 4, 5, 5, 1, 4, 1, 2, 3, 4, 5. What's that number? How many miles is that? Make sure I do that right. Yeah, Jackson?
4,551,400,000 miles.
Is that a lot?
That's cool.
Yeah, it's a big, and that's, see, like no one actually took a ruler and stretched it out, right? How in the world did they measure this?
On the science test, it said how do you measure it, and then one of the answers was like meters thick.
Yeah, a very big and
Everybody knows
sturdy
it's
meters
not
thick.
easy to measure.
They're actually going to use light to measure that, and then you can convert light years into
Yeah, it was on something.
your miles. So that's a big number. Okay, just when you thought that was over, we get the actual new part of the lesson here. Okay, go back to 507, and this is going to tie scientific notation with what you were doing the last two lessons, okay? This is cool. I love this, guys. The thing is this. It's example 3. You're going to now put in the power rules and the division and the multiplication, and how does that even work out? Okay, so example 3. We'll start with A. We have 610 times 2,500,000,000. That's a big number. Now you can multiply it just like you normally do, but this is what we are going to do. What we're going to do is we're going to convert both of these numbers, 610 and 2,500,000,000, into scientific notation and then multiply. Okay, so how would you write 610 in scientific notation? Jenna? 6.1 times 10 to the second. That is correct. 6.1 times 10 to the second. So this is, oh yeah, I remember that now. It's a big number. And when I say big, I mean bigger than 1. Anything that's bigger than 1 is a big number. A lot of them are going to be big, and some are going to be very big. How would you write 2,500,000,000 in scientific notation? Brian, do you know? Good, 9 times. And it becomes 2.5 times 10 to the 9th. Mr. A, you just made this more difficult. Well, let's see what happens. Okay, the biggest part about multiplying these two numbers that we don't really want to do on our own is if you drop a 0, that makes the whole distance different. Like there's a difference between 1,000,000 and 100,000. Okay, that's may not seem significant, but it is. Okay. What we're going to do here is realize what's going on between 6.1 and 10 to the second. What operation? Multiplied. What's going on between 2.5 and 10 to the 9th? Multiplication. What's going on between 6.1 times 10 to the second and 2.5 times 10 to the 9th? So do we have to multiply in a certain order? No. Can we multiply the numbers first? Go ahead and do that. 6.1 times 2.5. Figure out what that is. So 6.1 times 2.5. And then don't forget where the decimal goes.
Between 5 and
2. Good. Yeah, the 5 and the 2 here. Good. So I get 15.25. Great. That's not too bad. Then what happens when I multiply 10 to the second times 10 to the 9th? Do they have the same base? 10 to the 9th and 10 to the second, right? You're multiplying them, so what do you do with those exponents?
You
Add them. You get times 10 to the 11th. Ta-da! You are almost there. What's wrong with my scientific notation? It looks so nice right now. Didn't circle it? Yeah, I guess I didn't do that.
That's your solution.
Lucy, what's wrong with it?
You have to make decimal point over.
Okay, this is how you want to think of it, or you can actually write it out this way. Okay, do you guys see that this is not proper scientific notation because this A, this number A, is not between 1 and 10, right? It's above 10. So I can do it this way, and let's see if you guys can get it. Can anyone write this in scientific notation properly? Just this part right here. How do you write this as proper scientific notation? By the way, is it big or small? It's technically my definition. Big. Okay. Jenna. 10 to the what? Sorry, what's that exponent? If it's a big number, if it's a positive.
Negative.
Positive one. Right here. So I couldn't hear you, and that's my fault. I'm just, I'm getting old.
I thought it was wrong.
Can I say that? Can we just blame it on my age? You know what I heard a 7th grader say? Mr. A, you're close to 50.
No.
And I had to catch myself. And I said, go. And then I thought a student probably said, no, don't go. I was just kidding.
Was that Dave?
No, it was a young lady. Okay, anyway, this is not proper scientific notation because what happens when I combine these two together? Say it. 1.525 times 10 to the 12th. That's my final answer. 1.525 times 10 to the 12th. Let's do another one. B. Oh, there's a C. If you didn't see it, yes, sir. Okay, here's where I'm going to say it's up to you, but don't blame me if it's wrong because of this. Okay, you could technically go from 15.25 times 10 to the 11th, this step right here. You can go directly into that last 1.52 times 10 to the 12th. But you got to make sure either you add 1 or you subtract 1. How do you know if it's adding or subtracting? Well, you better figure it out. Okay. B. 0.000009 times 3,700. Okay. You can work it out and you can get all your decimals straightened out. But I want it in scientific notation. How can I write the first number in scientific notation? Jack? To the negative 6, right? Because it's a small number. What about the second number? Somebody else? What about the second number? What does that become? Harrison?
It would be 3.7 to the third, right?
Times 10 to the third. Okay, big number. Small number. Small number is being multiplied by a big number. Does anyone happen to know, though, is my result going to be a big number or a small number? What do you think, and how do you think you might figure that, like why that's the case? How many of you say it's going to end up a big number? How many of you say it's going to end up a small number? How many of you say it's a small number can tell me maybe why? Carrick? Because you seem pretty determined. I think you know. What do you think?
Because it's negative 6 and it's greater than positive 3.
Yeah, you're comparing these two numbers, and that's bigger. So I'm going to go with that. That's usually a good way to figure it out. Okay, good. Do I have to multiply in this order? Do I have to do this times this, then times that, then times that? Nope. I'm going to multiply the numbers together. So what's 9 times 3.7? 33.3. Okay, good. I get 33.3 times 10 to the negative third. How'd you get negative 3 up there?
Negative 6 plus 3.
Okay, good. You added those exponents since they're being multiplied. Is that proper scientific notation? No. By the way, is this a big or small number? Big number. Here's another way you can do it. Doesn't it have to be 3.33? Don't you have to move that decimal once? Now, if this were a big number, what happens to the exponent? If it were a big number, it went up 1. You moved it once, so it should be 10 to the negative second. 3.33 times 10 to the negative. So that's one way you could do it, Brian. Like you could do it without doing that intermediate step. Is that a big or a small number?
Big.
Which one?
Medium.
Which one? It's one or the other. Small, because what's the exponent? Negative. Okay, good. Last one, the toughest one. And then I'll let you go. C, it's in the next page. It's almost not there.
First C. Here.
Dun, dun, dun. You get this problem here. Uh-oh. I just got to make sure I write it the correct way. Okay, I'm looking at it thinking to myself, what? Okay, do you guys remember from this morning, can I deal with the numbers? And then can I deal with the base tens? Okay, so you're like, the numbers, all the problems that have division, I think you have 2 or 3, so not many, they're going to be terminated. They're not going to repeat. You're not going to get this repeating number or this endless number. So you're going to divide these two. You're going to do 2.0286. Make sure I wrote that right. Divided by 3.15. That's your first step. Divide that out. Can I divide that the way it is? No. How many times do I have to move the decimal here? Sorry? Twice. 1, 2. 1, 2. So it comes up here. Does 315 go into 202? No. Does it go into 2028? How many times? Too big. Bit too big. 5 or 6 is a good one. Someone tests out 5 and someone tests out 6. It's one of those.
5 is 1575.
15, okay. Ooh, which one is it? 6. So 6 times, and that was 1890? 1890. So 8, carry, all right, we're going to borrow. Be careful when you're borrowing. Uh-oh. 315 goes to 1386. I think I heard it.
4 times.
4 times is a good guess. So I'll go here. 1260. That'll be close. Oh no, the endless problem. The endless problem. It ends here. 0.644. That's it, evenly. If it goes on forever, something happened in my division. So I'm just telling you, I looked at all the problems. So what's 2.0286 divided by 3.15? 0.644. I'm just taking it just the way it was given in my answer. What's 10 to the 8th over 10 to the 3rd? 10 to the 5th. Yay, I have my answer.
6.44.
Are you sure it's to the 4th or to the 6th? Sure? Why are you sure? Is this a small number?
Yeah.
Did you have to move it over once?
Yeah.
So it's a small number. What happened to that value? It went down 1. So you're correct. Did I make you doubt a little bit? No? That's too bad. Okay. All right, guys. You kind of get how to work this out? Okay. Your homework is 19 to 41 odd. And then 50. So you guys did well, by the way, paying attention, answering questions. That's good. I hope it goes well in this lesson. Just don't forget, big numbers, small numbers, they're different. Goodbye, Swivl.